Today, oh wait.
It's there.
Okay, cool. Today we are learning about imaginary numbers.
Oh no.
So, we had this discussion in an earlier class. So the main reason we have imaginary numbers is because in math, every problem has a solution, right? Whereas before, we've been solving, and if we had like the square root of -9, we would write it does not exist, right? Well, it does not exist over real numbers, because you can't square root a negative number if you're only talking about real numbers, but if you start to include imaginary numbers, then you can. So,
Got that.
is the variable we give to imaginary numbers. Finally, a variable that makes sense. And I is defined to be the square root of -1. Well, the good thing about I is that you can do different things with it. So if you take I and you square it,
Amanda.
if you take I and you square it, what happens if you square something and then square root it?
It goes away.
It goes away, right? So the square root of -1 squared is just what?
1.
That -1,
Oh.
right? Because we undo the square root of the squaring.
But when it negative times negative is positive?
Yes, but we're not there yet. So hang tight. Now I to the third. Remember with your exponents, if you have like x to the third and x to the 10th, what do you do with those exponents?
Add.
You add them, right? Well, we have never found a use for going in reverse order until now. We can also say x to the 13th, we'll break it apart. You can call it x to the third and x to the 10th. Again, we've never had a use for that until now. Well, if we've got x to the third, or I to the third, excuse me, we can call that I to the second times I to the first. Because what is I to the second? What did we just say?
Oh! And then you would add the exponent, so it'd be I3.
So, yes, so if it is I to the third, that's where we're starting. So if we add our exponents, that takes us to I third. But what is I to the second? What did we just say right up above?
Negative 1.
-1. So what happens when we have -1 times I? What would we call it?
Negative 1I.
Yeah, -1I or just negative
So
I.
the negative 1I is always going to be there.
Wait a minute. I'm a little lost. How did we know when you were like, I to the second equals -1? Like, where did that kind of come from?
From right up above, where we said, oh, if you square root something and then square it, they cancel.
Oh, okay.
So that's why we broke our I to the third apart into our I to the second and I to the first.
Okay.
Now I to the fourth, let's break that guy into
3 and 1.
Sure, we can do 3 and 1.
2 and 2.
We can also do 2 and 2. Because what's I to the second?
Negative 1.
-1. So Ellie, here is your a negative times a negative is a positive.
Positive.
Now, the nice thing about I is that it goes in a circle. It's cyclical, goes in a cycle. So I to the fifth, we can
2 and
call,
3.
we could do 2 and 3. We always like to split it into 4 though. Because what's I to the fourth?
1.
1. And what's 1 times whatever? Just whatever that
That's always that
number
number.
Oh, whatever.
Yeah. So then we call it I to the fourth times I to the first. And I to the fourth we just said was 1. So 1 times I is I.
Why do you use I? Does that
I-
stand for imaginary, or
Correct.
do you also use I's?
No, we do I to show that it's imaginary. So unlike variables, where if I say solve the equation, I could give you an x, a t, a q, a p, or whatever. I, whenever you see it, always means imaginary number.
Wait.
Yep.
So, like, if on a problem, like, if this was a section where you're like, find that. So J5 is always going to be I. Or is it going to, like, totally differ? Or, like,
I to the fifth is
this-
always going to be I.
Okay, and just, like,
Yep.
I to the fourth always going to be 1.
Yes.
Okay.
Yep. And so whenever we're unsure, we always break it into I to the fourths. Because
Okay.
those are always going to be
Wait,
ones.
so
Okay.
J6 is going to be
I.
J6.
These are I's.
Oh, geez, my glasses.
J6.
Wait, well, can I do this? Would be 4 and 2.
Yep.
And then the 2 is negative 1.
Right.
And then the 4 is
What?
negative 1.
Is positive runs,
So
right?
negative 1.
Right.
Dude,
Perfect.
that's some
So-
smarty worthy.
I to the fourth,
That's smart.
we just said
That
from
is
up above is
smarty
1. I to the second, we said from up above is -1. 1 times -1 is -1.
Amanda.
Can you do I5 and I5? No, that doesn't add to 25.
Right, because they.
I 20, I 5.
We could, however, we always want to break it into something with 4.
Oh yeah.
Because 4, I to the 4th is 1. I
4
to
is
the 8th
21.
is 1.
Is it 24?
24 and 1. There we go.
5 or 5 and 5.
But that would be multiplied. Remember, we add.
I'm just not kidding.
Oh, okay.
So any 4, 14, 4, 24, 34. As long as it's 4.
Not ending with a 4, but a multiple of 4. So 4, 8, 12, 16, 20, 24, 28, 32. Because anything, any I to the power of a multiple of 4 is just 1.
And then that would be 1, which is negative.
Right.
Oh my god. That's gonna be in the recording for the juniors.
Wait,
Oh,
that
God.
records.
Wait, I don't get why.
Because I to the 24th, 24 is a multiple of 4.
Yeah, they're recording.
So any of the 4s.
It's like screen recording with audio, so they can
Hold
hear
on,
everything.
team.
Sorry.
Trying to explain. I to any power that's a multiple of 4 always goes back to
It's
1.
embarrassing.
So it always circles back around. So you've got I squared is negative 1, I to the 3rd is negative I to the 4th is 1. And so then I to the 5th is the same thing as I to the 1st. I to the 6th is the same thing as I to the 2nd, which is negative 1.
So it's
Yep.
just okay.
So we're basically looking for the closest multiple of 4.
Gotcha.
Okay, and then we use I whenever you've got the square root of a negative number. So the square root of negative r, we'd move that I out front and get rid of the negative under the radical. So, like for example, 1a, if we want to solve, what's the only thing we have to do to both sides?
Square
Square root both sides, and what do we remember when we take the square root?
It's always
-1, right?
Well, as of yesterday,
break it down.
we do want to break it down, yes.
You can't break it
But
down negative.
when we put in a square root, we need plus or minus. That's what I was going for.
Oh. We're all like, break it down.
So we've got plus or minus the square root of negative 38. Well, we just said we can break it down, right? So whenever you've got a negative, call it the square root of negative 1 times the square root of that positive number,
That would equal negative 38.
because that would equal negative 38, right? And what is the square root of negative 1?
I.
So our
Sorry.
final answer
That was good, Pierce.
is plus or minus I radical 38. Now, if we could break down 38 as well, we could. We should. But the only things that multiply to 38 are 19 and 2. So, we cannot break it down.
Okay.
Is that a scarf?
It is.
Really?
No, that's
Is
a
it?
shawl.
It is a
A
scarf.
shawl?
According to Old Navy, where I purchased it, it is a scarf.
It's like those big scarves that you can, like, wrap around.
Okay, so in B, I want to do what first to solve for x?
Move the 3. Just kidding.
Move, not the 3.
The 33.
The 30.
Minus 33. 30. 5x2 equals 30.
5x squared equals negative 30.
And then divide.
Get in the chair. No, and then divide.
Sorry.
So negative 6.
Mm-hmm. X squared is negative 6.
Where were you?
I was having.
So then when we solve, we take the positive and negative square root of both sides.
That would be 1. And negative 6, we said would be.
Okay, whoa, Pierce.
That's not exact.
You're way ahead of us.
No,
I'm
not
just
anymore.
kidding.
What did we say negative 6 was? We didn't go to negative 6, we had 25.
No, so not I to the 6th, but the square root of negative 6. So the square root of a negative number, just like before, you say, okay, take that negative out front, make it an I. Right. And then the 6 is still under the radical.
Does that mean the juniors
I
are coming?
Square root 6. Not yet. We still have minutes, I think.
I don't know when they come back.
I know, I
This
kinda
is
like
screen
it.
recording all on their notes they're gonna look
If
at.
we could break it down more, we should. So if it was like a square
I don't
root
feel
of
bad.
8, we should,
That's
but
okay.
we can't. So our final answer is plus or minus I root 6.
Yeah, I don't
Wait,
really
why did
get
you
this
say
yet.
Because we can break down the square root of 8 and pop the square root of 4 and the square root of 2. Just 2 square root 2. Okay, now we can do operations with complex numbers. We can add, subtract, multiply, divide them. Complex numbers can always be written as A plus BI. And this is standard form for a complex number.
Complex numbers would be like what we said.
Right. So complex numbers just mean that they have a real part, we call it. So the A would be the real part. And then your BI is your imaginary part. So complex numbers have real and imaginary numbers. And then, in our next sentence, it says, if b is not 0, then a plus bi is an imaginary number. So, if b is not 0, altogether, if you've got an I, basically, you've got an imaginary number. Now, if b is 0, what happens?
It just is 0.
Right, so then you just have a, which was your real part the whole time. So if b is 0, you have a real number. So together, your real and imaginary numbers make up your complex numbers. Kind of like your rationals and irrationals make up your reals. Then to add or subtract two complex numbers, you just combine like terms, basically. So if you've got a plus bi and then c plus di, what you do is you combine,
A sheep.
right, bless you,
Thank
the
you.
two real parts.
A squared
Thanks,
plus
Mando.
B squared.
We're not squaring anything, we're just adding. It's kind of like if you have 3 plus 4x plus 7 plus 9x.
So 2A.
4 A B C.
You combine like terms. I'm sticking with it. We combine like terms.
It's okay, Amanda. I was thinking the same thing.
Wait, how?
She's
You were thinking of
I'm trying to make her feel better.
Would it just be A, B, right?
hang tight. No, so it's just combining like just hold on. Now when we multiply complex numbers, we FOIL. Get excited.
Yay.
Woot.
To divide complex numbers or to remove imaginary numbers from our denominator. So just like radicals, we cannot have imaginary numbers in our denominator.
Wait, why is BI and B the same thing?
BI and what?
B.
So we just have the I out here. See?
What?
Just
Go with it.
Just go with it.
we're gonna combine the terms. That's really what it is. So in order to get rid of our imaginary number in our denominator, we multiply top and bottom by our complex conjugate. We have dealt with multiplying numerators and denominators by conjugates before, which is when we do, like if we saw an 2 plus radical 3, we multiply top and bottom by 2 minus radical 3, right? Well, now if we see 2 plus 3i, we'll multiply top and bottom by 2 minus 3i. So, let's jump into it.
On the foil.
We're adding though,
I know.
Yeah.
But don't you foil?
not if we're adding. If we're adding, we just combine like terms. So our real parts are 9 and negative 6. What do 9 and negative 6 combine to become? 3. We
3.
just add them.
Oh.
And then negative I and 7i.
6I.
Exactly.
Oh, I like these better than whatever we were doing up front.
But then you can't really add 3 plus 6I because they're not linked together.
Exactly. So we leave it.
Okay, Piers.
You know, some fun.
Now in part B, this time we are subtracting. So what do you think we do with that minus sign?
We
Distribute it.
yeah.
We get to distribute it.
That's what I
We've
meant.
got 2 of them, so we distribute both.
But you're not foiling.
Correct. we have
She's
negative
really trying to
4.
get that foiling.
Minus 1 minus I.
-5 minus -I. No, we're
No,
subtracting.
Oh, yay. Well, okay, yes. So, pause. I'm just distributing first. Let's just do that. So,
Okay.
minus 1 minus I minus 5 minus 9i.
Okay.
Combine.
Yeah, now we've got all the real parts lined up. So, we've got negative 4, negative 1, and negative 5.
-10.
Exactly.
Dang.
Piers?
And then our
Wow.
imaginary parts, negative I and negative 9i.
-10I.
Exactly. And we are done.
I got this.
Oh.
You ready?
Yeah.
She's trying to do that. Distribute.
I suppose
Do we have word problems?
I don't believe so.
Oh.
There are some that we could do because this is used in the real world, but I think I took it off your homework.
This is using the word.
This is using the world. People
Okay,
use
in
eyes.
C, what do we do, Ellie?
Negative 9i. I mean 9i.
Okay, there we go. We distribute 9i.
Negative or negative I 2.
Yes, negative I squared. Go back to the beginning.
You can pull out.
Right, I squared is what? Careful. I squared was negative 1. Right. Right, so we have 9i minus a negative 1. So we add. We have 9i plus 1. But we always write them in a plus bi. So we always put the imaginary part second. So we're going to flip-flop this.
1 plus 9.
Exactly.
I didn't do anything.
In D, we foil.
You said coil.
Nope, foil.
Everyone goes where?
15.
3 times 5. Our firsts, we get 15.
Negative 3i.
Our outsides are negative 3i, and our insides are positive 5i.
Negative 2 or negative I squared.
Right, negative I squared. Good job.
And then
Positive.
2i. 15 plus 2i.
So we start to combine like terms.
Crap,
So
plus 2i.
we have 15, and we have a positive 2i. But then what about that minus I squared?
Change it to 1.
Right, change it to negative 1. So minus
Crap.
negative 1, so we end up adding 1, positive 1, right? So 15 plus 2i plus 1.
But we didn't change the form.
Right, and we need to combine our like terms one more time.
16
16 plus 2i.
Oh no.
Can we hide?
No!
Can we? No.
I don't like it.
I don't either.
God, you guys are terrible.
No, I like it when it's just
I know. I learned better.
I'm not moving.
Go away.
Hi guys. Okay,
Can I stop
recording?
recording?
Yes, please, for the love of